Hi, I am Cam Calderon, and this is the case study for week 3 lecture. So we are going to cover a very interesting case about global temperature, climate change, and this is going to help us a lot to arrive to the notion or to the argument that we need to do something to protect our planet. So follow me to my full desktop. Okay, so I am here in learning materials, R code, and I'm going to download the R code for global warming. Yes, I did. So it's now in my downloads. I will open it from my downloads, not a problem. Well, please disregard all of this because I was working on the code first. So I think you will not have anything here. But if you go here, file, open file, and then find the R script wall warming, yes, so then you will have a very nice set in there. Previously, I went into download this data set here. I choose monthly because I want to find seasons, and because the lecture was obviously about seasons, trends, and the reminder. So that is why I click on here and I downloaded a data set that I needed to fix it slightly because the dates were not in an appropriate format. But apart from that, I did not do much. I focus on a data set from NASA. This is actually taken from NASA. So I think that is very interesting. As you can see, we have two sources for the global temperature. I just use this one, this temp. Why? Because that is the NASA reading. I think you can use two as well if you want. Test the other one and probably find the, the, the same findings for the other data set. All right, that data set, you are going to find it in your folder datasets here in Blackboard. Let's come back to R. So we covered this first in our lab. So I'm going to lab for week 2 was on how to download CSV and Excel files. So I am writing here comments. In order to write comments to my code, I just type below library opens the library of commands to read external files. Yes, and I said this everything that is to the left of this is a name. So this is global warming. This is a name, and I set the global warming to the data set that I download from the page that I showed you before. So everything is fine until line number 4. Yes, normal. So I am going to I'm going to stand here in line 3, control enter and control enter. Then I have line number 6, which is a name. I am using this name, and this sign dollar means that I am looking at the column date. Yes, of my Excel file, and I am asking R to choose the format as day, month, and year, separated by this slash. So that is all I did there. So Control Enter. Yes. And then I am going to open other library, which is Tidyverse. I had to download this library because I had a problem in the order of my data, that the data I download first. So I have to arrange and sort the data by date. So I open this library, and then I will use from that library the command arrange. Yes. So with that command arrange, I will ask R to sort the global warming file or data or object by the column date. So I start anywhere in line number 9 and control enter. I can even step because my all of this just because of that reason. Okay, so the next command is to view the object that contains my data source. I can delete this column. I will leave it in there. We have the date and we have the mean. The dates are since 1880 up until 2016. We have a lot of months there, which is very particularly I like that. So what we are going to do, I am going to call this object G warming, and then I'm going to use the sign dollar to load or to look at this column mean. So in doing that, I am plotting that column mean, and I am asking with type L a plot with lines that you can. Then, as you can see, we do not have here any appropriate GS. So I'm going to make this a column G warming sign first time that you are using a time series command. So I'm going to type here time series command ts. This command simply tell R that this is a time series and that the time series starts in certain date and finish date in the fashion that is in here. This is the year. We start in 1880, period 1, and we finish in 2016, month 12. What is the frequency of this data? Well, 12, which because the data is in months, and each year has 12 months. So 12. So if I start anywhere here, I will get my global.ts. Yes. And you can use this command if you want to aggregate everything by means. Yes. But to be honest, we will not use this now. I mean, we can look how it looks if you want. So let's hit here the line 16, control enter, and let's plot that line 16, that object global dot annual. Problem with global, I spelled wrongly. Very nice here. As you can see, we to be honest, we are going to work with global TS, which is the plot what we had before, and very nicely we have now the GS here, which makes a lot of makes yeah, just by looking, you know that the Earth is getting hot. It doesn't really matter if it was the man or not. I think that debate is probably not very important. We need to do something, you know, because otherwise um, the human race can be extinct very soon, like just a few years, probably from 2050 or 2070, something like that, depending on how is the behavior of the global warming. So here I can like use a line to find the trend. So that is what I'm going to do now. So I'm going to say, I'm going to tell R that this name, new series, is going to be just the 70s up until 2016. So something from here to here. Yes, with the command window, I will just extract certain portion of the time series. hit this command a window, and then I say global TS, this data with time. It starts in 1970 and it finishes in 2016, period 12. This is new series, that name. So I'm going to record there that time frame. And then I will use this command time, yes, just to say that is a new series. If you want, we can go here and type question mark time in order to get to know what is that command. Yes, time creates the vector of times at which a time series was sampled. Yes, which is interesting because with this command we can regress the new time series with that command new series. The idea is to find a plot. We are going to plot a new series. Yes, let's plot new series. So let's plot all of this, and as you can see, we have plot the time series here, right? But we have a problem here. Error in eval prefers object new time not found. Well, I forgot to go to line 22, control enter, and then plot this. And as you can see, I have here this line that crosses all this data. We can say now that this is a trend and that this is the data. But in our lecture, we covered that apart from trend, we would like to get to know what are the seasonalities. That data has a seasonality that we will be very interesting, yes, because we can need. So there are a couple of commands. The first one is decompose. I don't like this command because it's a little bit old, so we will use as well the. So let's stop in, or let's stand in line 25 and control enter. So we are going to plot decompose. As you can see, the trend is not very clear. Well, I want to get here a line. Indeed, with this command, I can use the additive um, um, seasonality and the multiplicative seasonality. Let's see if it takes, this is the multiplicative seasonality. When you have a problem, guys, which as I am having here, you can all the time type a question mark, decompose. Surely is going to tell me what is the problem that I have. So what is the type? I type the additive and multiplicative. So I can use these two. There is something that I am not seeing properly. What I'm going to do is just Control C and Control V, just in case I am. Here. Oh, no, actually, it's good, guys. I do not know what I was doing. I say to R that this is a name global decom that is going to save the time series decomposition of my time warming. Now I'm going to plot that. As you can see, now I have the multiplicative. It doesn't really work, as you can see. Apart from this, I can save the trend and the seasonal trend by using or by exploring the global decomposition dollar trend and dollar seasonal, because it looks at these columns and then plot that, yes, but it doesn't, yes, it doesn't feel nice. So I am not going to record this. I'm going actually to leave that because I think this didn't work. Yes, if you have code, so you can have it in there maybe for another opportunity, another project. But to be honest, for this project, it's not worth global warming, don't we? So while we are going to open or to jump here to line 32, and we are going to require the package graphics. So Control Enter, and we require like a library that is important for us to open STL. Now I am going to plot with the command STL. If you want, I can question mark STL. What is that? STL is the composite time series into seasonal, trend, and irregular components using lowest acronym STL, right? So that is telling R plot the position of new series, and we are going to use the periodic here argument. So I think we can, yes, but well, I think will take us probably a few seconds. Let's try to find pair. So periodic, see. So we can see what happens. So we go here to line 33, Control Enter. Yes, again the trend is not working. What we are going to do is to carry on telling R that the S window is a either the character string periodic or the spanning lags of the lowest window for the seasonal extraction. So what is trying to find is like a periodic seasonality. Yes, according to Cleveland et al. So it's according to certain paper you can also find on this help guide. And we are using T window, which is the spanning lags of the lowest of windows for trend expansion. So it's also playing with that window of trend, yes, to try to find the trend extraction in certain window. I am using 300 observations because I have a lot of points in my data. So let's do Control Enter here, yes, and I have a very, at least a much better. That is something that is actually looking much better, right? So what I'm going to do is to say to global decoms save uh, this plot that we just have done. So new dot series, which contains the time series for global warming, S window pair, we already did that before, and T window equal 300 because I have lots of information. So I am extending, like making bigger this window in order to for R to try to find the trend. So let's go to line 35 and Control Enter. I recorded here in this name this decomposition, and now I am going to plot the name, Control Enter. So I will have exactly the same stuff. What is interesting is that I can use these lines, yes, in order to make like a single graph. So going to call decom1 a data frame of decom time series. So global decoms, if you go here, we have a list of tables, yes, but to be honest, we are interested in the list time series, which records this, yes, this table. So I'm going to show you what is that. Control Enter in line 37, and I can actually view that. So the Enter. As you can see, I have extracted this in numbers: the season, the trend, yes. So I am going then to tsplot, and oh, this is what we have, guys. This is the seasonality that we extracted from the data, and here we have a very both trends are is telling us that from the 70s up until 2016, the planet Earth has increased the temperature 0.8 degrees. Do you know how many degrees do we like we need to in order to get like the apocalypse on Earth? Please review uh, that information. I think that will be very useful in order to complete this task. Okay, guys, I hope you have enjoyed this short video. I have done my best to explain anything, but if you have a question, please email me. Okay, thank you very much.